Hello everyone, it's been a while and I've been thinking about what kind of project to tackle next, and I've decided to do something 3D related. I did some tests using RealityKit. That wasn't very successful, especially as Xcode kept crashing. But we can also use RealityKit to make 3D games even if we are not using an augmented reality setup. So you don't have to use cameras and overlays and integrate virtual and real world objects. You can also use it as a sort of 3D engine. So that's what we're going to do. What I'm looking for is I want to make a sort of dungeon crawler, something like Eye of the Beholder, where you have a view of a dungeon where you can step through step by step. So these used to be in using sprites in 2D. We're going to use the 3D engine, but the gameplay will be more or less the same. So we can step through it one tile at a time. And the reason I want to do that is one of the things I liked when playing these games is they basically were as fast as you were able to click places or memorize your surroundings. And I want to use that as a sort of gameplay advantage. So if something happens, you can kite around very easily, you can run away very easily, as long as you know where you're going and you're quick enough. And that can only happen if there's more or less no limit to how fast you can go from one tile to another. So let's get started. So I'm gonna set a timer for 25 minutes. And the goal for this first 25 minutes is to get more or less something resembling a corridor on the screen. So let's start. Let's create a new Xcode project. And we'll do a macOS app. And we can call it a dungeon crawler. We can keep the defaults, put it in somewhere, create the project. Now we can start with build and run. Okay, so there's the default standard Swift UI view. Next time we run it, it will be quicker, so don't worry. So this is a Swift UI app, meaning that we need to find a way of getting RealityKit into Swift UI. Now, just one solution would be to import RealityKit and create a reality view and use that one. However, this one has a couple of disadvantages, in particular in how much control you have over how it looks. Reality View is really set up for using Vision OS, and as far as I understand, you can't do, for instance, post-processing effects in this data type. So that's why we're not going to use it, and we're going to use the classic AR view, and that means that we need to integrate that into Swift UI. So let's do that first. So I'll call this a game view, and this requires Swift UI and RealityKit. And then I can create a struct called game view, and this isn't a view, this will be a NS view representable. If you make this for iOS, then this would be a UI view representable, and this is a protocol you can use to wrap a UI kit or a Cocoa view into Swift UI. And this requires two functions, a make NS view and an update NS view. And this one will return an AR view and we can just say, well, let's create a view, and we can return this view and add stuff to the view in between. And we have an update and this view, and this one should take an NS view type, and this doesn't need to do anything yet, just yet. Okay, so we could use this one here now, create a game view, again run our program, and it will be kind of boring because there is nothing in the view. So let's quickly add at least something in the view that we can see something. So I'll create a new method called setup view, and this will take our view, and this will be a private function. And we will use this to add stuff to our view, and we'll start by adding a cube. So we need to do that, we need a material. We can do a simple material. We can give it a color, for instance blue. We can make it metallic a bit. Then we need to have a cube entity that takes a geometry component, if I'm correct. This I always need to search up, so that's why we have the help view open. Let's see, so the first step would be to add an entity. Let's see, we can create an entity using the model component, of course. So we need a model component. This needs a mesh, and we can generate, for instance, a box with a size of 0.5, and we'll use our cube material. So we now have an entity, and we can anchor that entity somewhere in the world. And the way RealityKit does that is you need an anchor entity, and this takes a position. So let's add it to 0, 0, -1. And then we can take our cube anchor and add the entity as a child to it. And then we take our AR view, the scene, and we add the cube anchor to it. And if I don't miss anything, we should now see the cube in our view. Okay, there it is. Not very interesting yet, but one thing we can do is we can push it aside a bit so you can at least see that it's a 3D thing. Look, you can now sort of look past it. Okay, so there's a color. This is still really simple. So where should we go from here? Well, what I want to do is set off a sort of corridor, and we can let's create a new drawing. it will be sort of like and you as the player will be standing here looking into the corridor. So this is what I want to get working in this episode. So that means that we need a couple of cubes, and the first thing we should do is extract this into a function so we can create cubes as needed. So we'll create a cube, and this one can return an entity. I'm sorry, this should return an anchor. And this one should get passed in a roll position. And then we can use that position here. And we should now be able to create cubes. So if I pass in here in this roll position our previous position, we should have more or less the same result. Okay, let's continue. So we're able now to create anchor. So if I take a couple of positions, and this will be an array of SIMD3 floats. The first one should be at and then the back wall and then we can loop over let's see. Okay, the cubes should be size 1. So that's a bit too metallic for my taste. That's why they also appear very dark. Let's see, what was it called again? I'll set the metallic to 2 and the roughness to 7, so it should look a bit more diffuse now. Okay, this is more what I was looking for. So we have our, we could now have our corridor. We could even add one more wall part next to us. Okay, so this is starting to somewhat resemble a corridor. I know it still looks terrible, but don't worry, this will get better. What I notice is that the camera isn't exactly where I expected, so I want to add a camera as well. And to do that we need a camera. So it now has one at a sort of default position. I'll create a default perspective camera. I'll create we need an entity with a component Let's see what the camera exactly returns. Oh. The perspective camera is okay, we'll see. We need a camera anchor. We'll put it at 0 and we will take our camera anchor and add the camera as a child to it. And then we take our scene. Okay, let's run it again and see what happens. And now we can see into our world. The next thing I want to do is I want to add a floor and a ceiling. So let's create a floor. And this will be a floor entity. This will be another model entity that takes a mesh. And let's see, we need to generate a plane, and it can be, I know, 10 wide and 10 deep, and it needs a material. Let's create a different material for the floor. Okay, then we need a floor anchor. And we need to take our floor anchor and add the floor entity as a child. And add this to our view. Let's see if we can at least see it now. Okay, so we have a floor that already gives it a more grounded look. And we need a ceiling, and the ceiling will have the same material as the floor. But this one will be higher up. But we can't see it because the plane is one-sided. We need to flip the plane around the z-axis to be able to see it. So we'll take our anchor, transform rotation, and we'll create a new rotation. That's a SIMD quaternion. We rotate it by pi around the z-axis. It should now be upside down and now be visible. Okay, so we now see also our ceiling. And well, this one we can change into a LED. I'm quickly going to extract this into a function as well. Okay, let's continue. So we have a floor and a ceiling. The final thing I want to do is, if we run it, notice that There are no lights in this scene, however we can still see the world, and the reason is that it's creating a sort of default lighting from an invisible but default sky box, and the dark places you see are only from more or less shadows. We can do a bit better, we can control the light a bit more if we take a cube map that is almost completely black. That will make sure that we don't have any ambient lighting. There's no function to set ambient lighting direct. It needs to be through a file, and we can do that by creating more or less. Sure. I think it could be a 1x1, but if we take, for instance, if we create a completely black image, and we export this, then we need to create a folder here called, as long as it ends on with skybox, then we add this file, this image, into that skybox. Sure. And then we should be able to access it as a skybox. If I remember correctly, it's an environment resource let's see how this worked again. So we have a resource image, loading the resource. This is the async one, but I think there's also a synchronous one. I think it's this one. Alright, load is the one, that's the old one. And then you can do aview.environment is skybox resource. Okay, I'm going to stop this one for a bit. Let's see if we can at least load the file. Okay, that's fortunate that that happens. We'll continue working on the lighting in the next episode. Thanks for watching. Have a good day.